So welcome students. In this video let us look at what centroid is, and we'll also look at some of the properties of this centroid. So now the centroid of a triangle is the point of intersection of the medians of the triangle. And what is a median? A median is a line joining the vertex with the midpoint of the opposite side. So if you take the vertex A, the opposite side is the side BC. So if D is the midpoint of BC, then AD is the median. Similarly, BE is the next median. BE is the next median if E is the midpoint of AC. And the line joining C to the midpoint of AB, in this case denoted by F, is the third median. And the point of intersection of all these medians is called the centroid of the triangle. It is denoted by the letter G. And if you have a plate of the shape of a triangle, so the centroid turns out to be the center of gravity of the triangle also. So the centroid is also the center of gravity of the triangle. Now, what is the most basic property of the centroid that you need to understand? The centroid divides, G divides the median AD or BE or CF in the ratio 2:1, starting from vertex. This is the most important property of centroid. That is, if you take the median AD, G divides AD in the ratio 2:1. That means AG by GD is equal to BG by GE is equal to CG by GF is equal to 2:1. So the ratio is 2:1. So let us see why this property holds. So let us try to show that AG by GD is equal to 1. AG by GD is equal to 2:1. So to do that, let us take a construction. So the construction that I am going to do is, from D, draw a line parallel to B. So from D, draw a line parallel to B. So once you do this construction, you can start deriving your result. So first, in triangle BCE, D is the midpoint of BC, D is the midpoint of BC, right? And D, if this point is H, if this point is H, so DH is parallel to B, DH is parallel to B. So from the converse of midpoint theorem, H should be the midpoint of EC. So this line is starting from the midpoint of one of the side and is going parallel to one of the side of the triangle. So it has to divide the other side into two equal parts. So from the converse of midpoint theorem, CH is equal to HE. So this is equal to this is equal to X, say. So let us say that this is X and this is X. Now we know that E is the midpoint of AC and EC is equal to 2X. Hence AE is also equal to 2X. So if this is 2X, this is also equal to 2X. Now let us take this triangle ADH. So in triangle ADH, what can you see? So in triangle ADH, my GE is parallel to DH. GE is parallel to DH, right? GE is parallel to DH. So from basic proportionality theorem, what can you say? Because these two are parallel, from basic proportionality theorem, AG by GD by GD is equal to AE by EH. AE by EH. And what is AE? 2x by EH is x. That is equal to 2:1. Hence AG by GD is equal to 2:1, which is the result which we need to prove. So similarly, you can also prove that BG by GE is equal to 2:1 and CG by GF is equal to 2:1. And this result works in the reverse also. That is, if you take the median and you plot the point which divides the median in the ratio 2:1, this point will automatically be the centroid. Centroid divides the median in the ratio 2:1, and the point which divides median in the ratio 2:1 is the centroid. So the property works both ways. Now let us go to the next property. So in the next property, let us look at the lengths of the medians and a theorem called Apollonius theorem. So first, if I have the triangle ABC whose sides are ABC, and if I draw the median AD, can I find the length of this median in terms of ABC? That's the question. So to do that, I'll try to use the cosine rule. In triangle ABD. So in triangle ABD. So what is cosine rule? AD square is equal to C square plus A square by 4. Right? AD square is equal to this square plus this square minus 2 times C times A by 2 times cos of angle B. This 2 and this 2 gets cancelled. That is equal to C square plus A square by 4 minus AC times. What is cos B? Cos B can be expressed in terms of ABC. Cos B is nothing but A square plus C square minus B square by 2AC. And this AC and this AC gets cancelled. That is equal to C square plus A square by 4. C square plus A square by 4 minus A square by 2 minus C square by 2 minus C square by 2 plus B square by 2. So C square minus C square by 2 is C square by 2. A square by 4 minus A square by 2. A square by 4 minus A square by 2 is minus A square by 4. If I take the LCM here, the LCM is 4. So you have 4C square plus A square minus 2A square minus 2C square plus 2B square. That is equal to 4C square minus 2C square is 2C square. A square minus 2A square is minus A square. So 2C square plus 2B square minus A square by 4. This is AD square. Hence, the length of median AD is equal to root of 2C square plus 2B square minus A square divided by 2. So if you want the length of AD, it's nothing but square root of 2B square plus 2C square. 2 times the squares of the adjacent sides minus the length of square of the length of opposite side by 2. So if you want BE similarly, so if you want the median through B, if you want the length of this median BE, so that will be root of 2A square plus 2C square minus B square by 2. Similarly, if you want CF, CF will be equal to root of 2A square plus 2B square minus C square by 2. So this will give you the lengths of the medians of the triangle. So now once you have the medians of the triangle, you have something called Apollonius theorem, which says that AB square plus AC square, the squares of the sum of squares of two adjacent sides AB square plus AC square is equal to 2 times AD square plus BD square. AD square plus BD square. So this square plus this square, sum of squares of two adjacent sides is equal to 2 times the median square plus BD square. Okay, so this will be this theorem is called Apollonius theorem. This is also a very important theorem in properties of triangles. So you can very easily derive this once you use the formula for AD square. So AB square plus AC square is nothing but B square plus C square. The LHS is B square plus C square. So the RHS is 2 times, what is AD square? AD square is 2C square plus 2B square minus A square by 4 plus BD square is nothing but A square by 4. So if you simplify this, you'll just get the value of B square plus C square. So 2 times plus 2 times A square by 4. 2 times AD square plus 2 times BD square. So as you can very clearly see, A square by 2 and A square by 2 is getting cancelled. So this 2 and 2 gets cancelled to give you B square plus C square here. So 4C square plus 4B square by 4 is B square plus C square. So the sum of squares of two adjacent sides is equal to 2 times the length of the square of the corresponding median plus the square of half the opposite side. So I hope you have understood the lengths of medians and Apollonius theorem. So let's go forward to the next property. So the next property which you need to remember about the centroid is that the centroid divides the line joining the orthocenter and circumcenter. In any triangle, the centroid divides the line segment joining orthocenter and circumcenter in the ratio 2:1. So the orthocenter, the centroid and circumcenter will always be collinear in any triangle, and the centroid divides OC in the ratio 2:1. That's the property. So how can I say this? So let us take ABC as a triangle. Let's draw the altitude AL, and on this altitude AL you have the orthocenter H, and let us draw the perpendicular bisector of BC. So D is the midpoint of BC and DC is perpendicular to BC, and on this you have the circumcenter. So let us say that H is the point of intersection of the altitudes which lie on AL, and C is the point of intersection of the perpendicular bisectors which lie on the perpendicular bisector DC. So now what you need to prove is that the centroid divides HC in the ratio 2:1, or you can also write this as O or H. Now to prove this, the construction that I do is I'll join AD. So let us join AD. So if I join AD, the construction looks like this. So let us say that the point where this AD cuts HC be equal to the point, let us call it point P. Now I'll do some derivation. So the observation that I do is AD is the median. AD is the median, right? AD is the median because D is the midpoint, A is the vertex, and CD is parallel to AL because CD and DL are perpendicular to the same transversal. So the altitude will always be parallel to the perpendicular bisector. Now in triangles AHP and triangle DCP, AHP and DCP. So can you see that this angle is equal to this angle? Angle HPA is equal to angle DPC. These two angles are vertically opposite angles, hence they are equal. Next, angle CDP is equal to angle HAP. So this angle is equal to this angle because they are alternate angles, because these two are parallel to each other. CD is parallel to AL, hence these two angles are alternate angles. So in these two triangles, two angles are equal, so automatically the third angle will be equal. Hence these two triangles are similar to each other. Triangle AHP is similar to triangle DCP. And once the triangles are similar, the meaning is that the ratio of the sides is constant. So AH by CD is equal to HP by PC is equal to HP by PC is equal to AP by PD. But we know that AH is the distance between the orthocenter and the vertex. We have already derived this as 2r cos A. The distance between orthocenter and the vertex A is nothing but 2r cos A. We have already derived this. Next, what is the length of CD? CD is nothing but r cos A, right? We have done this derivation in the topic of sine rule. Just go through the derivation there. The distance between the circumcenter and the side is nothing but r cos A. So you can directly derive this by joining C to the vertex C. So this will be equal to r, and this angle will be exactly equal to A. So this will be r cos A. So for detailed derivation, go and see the derivation of sine rule. So r cos A, this is 2r cos A. So what is AH by CD? AH by CD is 2 by 1. That means HP by PC is also 2:1, and AP by PD is also 2:1. So now AP by PD is 2:1. That means this point P divides AD in the ratio 2:1. That means P should be exactly same as G, because the point which divides the median in the ratio 2:1 is nothing but the centroid. So this point will be the centroid of the triangle, and HP by PC will become HG by GC will be equal to 2:1. That's how we proved that the centroid divides the line segment joining orthocenter and circumcenter in the ratio 2:1. So OGC is 2:1. So these are the properties that you need to know about the centroid of the triangle. Thank you.